And just minimize it. We can actually help. I'm just gonna take it.
Okay. Hello, everyone. Thank you for being here. Can you hear me? Now, if you hear my voice, just chatting something like that, because thank you so much. Today we are going to talk about the introduction to R program. This workshop is designed for the people who are not familiar with the R program, and we are providing the hands-on experience, and we are show you how to write the code. And before the workshop, if you are a GPSA member, just please let us know that we need to send the email about the who are the GPSA member to the GPSA office. So let's start with.
Okay. Hello, everyone. Welcome. I'm Katie Thornton. I'm a data science major here at ETSU. And I'm also a member of the ETSU Statistical Consulting Lab. And what we do here, or where we're located, is we're in Gilbreth Hall. So this meeting right now, it's in 304 in Gilbreth on the top floor. Just down the hall in the offices is where our room is. So you can come by there Monday, Wednesday between 10 a.m. and 2 p.m. or Tuesday, Thursday, Friday between 10 a.m. and 3 p.m. if you need any help. If you want to see more of our past workshops, you can visit our YouTube channel. And this one will be on there after today as well. And you can contact us by email by emailing scl@etsu.edu. Okay, so there's a couple different ways that we can help you. What we do is we provide free consulting on research design, statistical analysis, and data management. Between the three consultants that we have, we're proficient in Python, R, SAS, data, and other programming languages as well. So here's two example cases of work that we have done and helped people with. The first case is with a faculty member who needed help or was having trouble brainstorming proper methodologies to analyze survey data. So our role in helping this person was suggesting related techniques, and in this case, such as natural language processing. And so the other case of an example of where we helped someone was a student, and their challenge was understanding regression analysis and how to use statistical software. And with that person, our role was to give learning experiences and guided model selection and interpretation. And these are just two examples of ways that we have helped people who have came into our lab. So any questions you might have, you can feel free to reach out to us at email or stop by the office at any time. Okay, so we'll get into today's presentation. Here's a little outline of what we're going to go over today. We're going to start with the introduction to R and R Studio, and we're going to understand basic R programming, and then we're going to also understand the data, and mainly we're going to discuss the tidyverse library, and then show some hands-on practice with Dippler and ggplot2 packages. Okay, so what is R? R is an open source and free programming language, object language, and it's commonly used in academics. The first time I used it was in, a very basic statistics class, and I'm still using it today, so it's very useful in academics. Okay, so now what is R Studio? R Studio is the IDE for the R programming language. So any work that you want to do with R, you can get it done in R Studio. There's several different parts to RStudio. Whenever you open it up, there is a script editor, and inside of the script editor is where you want to house all of your code. So anything you put in there, you can edit, you can reuse it, you can rerun it. So that's the purpose of the script editor. And then the console basically just shows you everything you run, and you can also, if you wanted to run some code in there, you can also run code inside of the console. Okay, and then you have your environment and history box up here on the right. That just shows you your data most of the time and history of things you've ran. And then finally, you get to see all your plots and results in the bottom right box. Okay, and we did send out a email with these links for download. If you'd like to download during this presentation, if you didn't get to before, you can go ahead and do that. Also, just note that you have to have R downloaded in order to install RStudio. So you would start by clicking the top link and downloading R, and then going to RStudio and installing that. Okay, so we're going to start with just some basics of programming in R. So as you can see up top, we've got our variable x, and what this arrow is, it's basically just an equals sign. It's the same thing as the equal sign. So we want to set this variable x 10. We want to give x this value 10. Okay, so that's what this first line of code is doing up here. And now we run that, and then you type x again, and you run it, and it calls the value 10. So you call x, and it remembers that it is 10. And if you do the same thing for like a sentence or a phrase or anything, so like below we did y is equal to the phrase hello R. And then you call y, and again, it will return hello R. So it remembers what you declare it as. Okay, and then continuing, if you look at the data frame function, this is how we can define a data frame here. And note that we are calling this data frame df, so that's the name of it. Okay, and then we have our name variable, and we're assigning two values. We gave it Katie and N1 for the name variable. And then for the major variable, we gave it two more values, data science and economics. Okay, so now we go back and we can call the data frame df, and it will return this table with the names that we gave it and then the majors that we gave it. Okay, couple basics, good things to know about programming in R. So R is case sensitive, so there are many languages out there that aren't. Like, for example, SAS, it doesn't matter the majority of the time if you have uppercase, lowercase, but in R it does matter. So if you were to type var1 with the capital V, it's not going to mean the same thing as var1 with a lowercase v. And similar to Python and other programming languages, you can add comments in R using the hashtag. So that's just a good way to note your code. Okay, and to save and rerun code, you write it in a script. So earlier when I was showing what RStudio looks like, you put all of your code in that script editor, and you can save it from there and rerun it later. And if you would like to run a command in the console, you just press enter. But then there's a couple different ways to run commands in a script. So in the script, you can either click the run button, or there's two keyboard shortcuts, one for Mac, one for Windows. For Windows, you can press Control Enter, and for Mac, you can press Command Return. and that will also execute your code. And then also for any function in R, you can type a question mark before the function name and run it with nothing in it, and it will pull up a help window to give you information about that specific function and help you out with any questions you might have.
Hello everyone, my name is Iman Jung. Now I'm talking about the understanding data. To understand data, here's the simple way to understand data. And first, we need to import the data, and then we transform the data, and then visualize data to find out the relationship between predictors, and then we need to model the data using our statistical knowledge about this, such as we can build a regression model, and we can build another classification model, such as the k-nearest neighbor and something like that. And what's important is the workflow is not a straight line. You should go and back and forth among the transforming, visualizing, and modeling to understand the data set. This cycle is very important or essential for understanding data deeply. And let's break down the data structure. Each cell means just the data value, and each row means observation, and each column is a variable. To analyze the data set, we suggest the tidyverse library, and the tidyverse library is a collection of the R packages designed for data science, and the library helps us to manipulate data or visualize data, and we can construct a model using the tidyverse library. And the tidyverse library contains the important packages such as ggplot_second, dplyr, tidyr, and reader, and pur and table. ggplot is for the data visualization, and dplyr is for the data management. So two important library is handled during the workshop, and one of them is dplyr library, and dplyr library help us manipulate data set, and it can filter data, and which means you can filter observation from the data set given any certain criteria. And you can select the important variable using select function, and you can group by the data set by any criteria, and you can summarize the variable using the summarize the function. Later, I'm going to use the pipe indicator. It looks like this and this to show the sequential operation. So you will see this pipe indicator in the script, our script. And next, ggplot library is an essential library for the data visualization. Using the ggplot library, you can build a plot or a chart layer by layer, and it is very convenient library to build the fancy graph or chart like that. And you can build a histogram or scatter plot, the time series plot, anything you can make the chart or plot using the ggplot_second library. So now we are going to move on to RStudio to manipulate the data set and visualize the data set. The data set we are going to handle is a penguin data set, the penguin data set contains 344 penguins observations and 8 variable like this. And let's move on to R Studio. Okay. Here is the R Studio page. And this area is for the R script. And this area is a console for seeing the output or something like that. And this area is for the program history or environment. And you can see the data set and the value using this area. And you can see any plot or graph in this area, and you can search for any packages using this button, and you can see any plot using click this button. And let's go to the R script. Before running the code, use the hotkey, which is suggested. But on Windows, you can use the Control and Enter key, and on Mac you can use the command key and the Return key. To install the package, essential packages, you learn this code, this line, Control Enter, and R is installing the library. This takes sometimes, you know. The tidyverse library contains a lot of R packages, so the installing takes a little more time. So done. And next, you install the dataset packages. The package's name is Palmer Penguin. Done, and you need to call the library before using the library. So call the tidyverse library and call the Palmer Penguins library, and now we are going to look at the importing data set. And before the importing data, you need to set the file path. You need to put the file path on the setwd function. I think we have already this is our file path, and you need to change the slash in this way. So we set the file path using the setwd function, and we can I create the example data set using the data point frame function, and you can see the data structure by typing the data, and you can see the data set by seeing this console area. And the write CSV function is to save the data we worked on. So we save the data. The data set name is ex_data, and we can read the data using the read.csv function. So run this code, and we read the data, our example data, and you can see the our example data, and by running this code, and see we can read the data. And the read_csv function is from the tidyverse library, so the same. So you can read the text format data set, and you can read the Excel format data set. However, you need to use another function or another, the library. So to read the text format data set, you need to use the read point table, and you need to use the read Excel library to read the different type of the data set. So now we are going to the deepler library. So before manipulating the data, we called the deepler library. So just type the penguins and run the code. You can see you can see the data structure on the the console area, and then you can use the view function to see the detail structure. So this is the our data set, penguins data set, and you can use the grims function to see the basic information of the penguins data set, and you can select the important variable using the select function. So run this code, and you can see the important variables such as the species, island, and bill length. And you can filter observation from data set, and you use the filter function to see the elderly penguins living in the Torgerson Island. So you can see the output on the console area, and you can sort the data set by ascending order or descending order. You use the arranged function. So you can see the output by sorting ascending order. So this is the descending order. And you can create the new variable using the mutate function. And this line means to create the BMI variable using the body mass and the flipper length variable. So I think it is difficult to find the difficult to see the variables. So we can select BMI, and you can see the BMI variable, and you can divide the data set into the group and summarize them using the group by function and the summarize function, and run the code. And you can see the output on the console area, and you can see the average mass of the Adderley penguin is 3,701. And we can use all of the functions like this. You need to use these pipe indicator to show the what's going on next, and this whole structure of this code is using the filter, and then select, and then mutate, and sort the group by, and summarize the average mass to get the mean value of the mean value, and then we final output is the average mass by sorting descending order. So run this code. So you can see the final output is this species island and average mass. And yeah, the final output is good, and you wanna share the report with the other people, and you need to save the data set, assign the data frame using this arrow sign. So save the data set, and if you want to see the data structure, so just typing the df. So after the typing the df, you can see the final output using the whole tidyverse functions.
Okay. Okay, so Inwan showed us the Dippler library. Now I'm going to go into talking about the ggplot2 library or package. Okay, so what I mentioned earlier was that you can put a question mark in front of any function and it's going to pull up a help page. So if you run this code here, question mark ggplot, it pulls up information about this specific function. And so this right here is example usage. So over on the left in the script editor, I entered in data equals penguins. This tells me data equals something. That's what I have to put inside the ggplot function. And then this AES is for the mapping. That's something I put in also. Like it goes through everything that you might need or want within this function, and then you at least have to have these two for it to run. Plus this down here, the geom_point. This is going to tell you what kind of plot it's gonna do. So scatter plots are really useful. And this specific one is asking for a scatter plot. So to get different plots, all you have to do is change the last word. So if I wanted a bar plot, I could do geom_bar. Okay, but I will show that later. Try to minimize this. Okay, so say we want to create a scatter plot where the x-axis is going to be the penguin's flipper length in millimeters, and the y-axis is going to be the penguin's body mass in grams. So that's exactly what this line of code here does. Okay, so if we run that, we've got a scatter plot, a very basic scatter plot with all of the data points scattered across this grid here. And already you can kind of tell it looks like there's some sort of linear relationship between the two, positive linear relationship. Okay, but say we want to go a step further because all the dots are just black and you can't tell any difference between species or anything. So this next line of code adds some color. So now this color equals species, if you add that in, it's going to color code the actual species, still using the geome point. So it's still going to be a scatter plot. So we run that. Now we have the same graph, but pretty, and color coded. So the red is the Adelaide penguin, the green is the chinstrap penguin, and then the blue is the, oh, it's not showing. Okay, 1 second. It's not showing the graph on Zoom, sorry. I'm gonna just show my screen. Screen. Now it's showing. Okay. Sorry, you guys, I was zooming in on the graph and Zoom couldn't see this, but okay. 1 second. Okay. Okay, here's the plot. So what I was saying is you can see the colors are different for each species of penguin here. And that was the gist. So 1 second. And close this. Okay. So now let's say we want to separate the species into 3 separate plots. So now this is going to be the same as before, but now we add this faucet wrap with species to separate the plots into 3 different scatter plots. So if we run that, okay, here is a nice plot with the species separated into each one. So previously, each species was overlapping each other. So the red and green, which is the Adelaide and chinstrap, they were all mixed in together. And now you can see them on the graph separately. So if you were to look at this, it looks like the Adelaide species inclines more quickly. The body mass inclines more quickly as the flipper length increases, and sort of the same story for the chinstrap penguin. And then the gentoo penguin is much different from these other species. Okay, now if you're presenting or you're wanting to show this data, you're wanting to show these plots to a client or just to someone else in a presentation, whatever the reason may be, you want to make it look pretty and formatted. So that's what this next line of code is going to do. So now everything is still pretty much the same, but now I'm going to add shape. I'm going to change the size. And then now I'm also adding labels, a title, a subtitle, the X and Y labels. Okay. And then this theme minimal just changes the background grid. So let's run that. Okay, and if we look at this, this is the same graph, same data and everything that we had last time, except now it's color coded. The species are coded by different shapes as well. We got a title, we got a subtitle, just looks a lot more visually pleasing. Okay, and like I was saying earlier, a scatter plot is not all that ggplot can do. It has a lot of different capabilities. So say that you wanted to create a bar plot and now you want to see how many penguins are on each island. So let's see, we run this code, that's what it's going to do for us. And now we can see that there's like 125 Gentoo penguins on Bisco. And you can also tell that the Adelaide penguins are on all the islands, where that's not the same for the Gentoo and the chinstrap. Okay, you could also have a histogram of penguin body mass. So that's what this next line of code does here. You run this. Now we get to see the distribution of the penguin body mass. So you can see like a lot of penguins are in this range here of, let's say, 3,500 to 4,000. And then there's a couple that are pretty big, above 6,000 grams, and a few that are below 3,000. So really useful. And then the last thing I'll show, say you wanted to compare flipper lengths across 3 species. Okay, so we're going to use a box plot to show this one. If we run this, now we've got box plots where you can see that the Gentoo has a much larger flipper length than the other 2 species of penguins. Okay, and these aren't, I showed a couple more, but these still aren't all the capabilities that ggplot2 has. There's just several different plots that you could use for almost any purpose. But with that, I'll head back over to our presentation. They can see. Okay, so if you're interested in any of our references, they're listed here. You can go back and look through those if you'd like. And thank you so much for listening to our workshop. If you have the time, please fill out our survey because it lets us know how we did, and we would like to hear your feedback. So if you have any questions, you can put them in the chat. We have a couple of people here in person as well. So if you have any questions, feel free to ask now. Otherwise, that's all we got.
And for the time limitation, we cannot cover the all features of the tidyverse library. So if you have any question, and please come to our lab and DOAT and just send us the email about your questions. Thank you.
I don't think you have any questions. Thank you. Do you guys have any questions? Intro to R.
Is that code on the references that you had, like all the code that you ran through?
That was code that we generated. So did you pre-register for the workshop? It's so my code, I didn't finish that until yesterday evening, so it wasn't included in the email that he sent yesterday. But his original code was. So the visualization code, I can send that as well if you'd like to see that.
Sure, that would be helpful.
The R for data science is a great resource to learn the R code. The book contains the ggplot or Deepler and something like that, the table and the T reader. So yeah, if you wanna learn more about the tidyverse, I recommend the book R for Data Science. And then I think there's another resource. I don't remember that because I'm feeling nervous about this presentation. So yeah, if you have any question, just send us the email about your concern or your question, and just come to our lab. Just yeah, so anytime within the hour of the time.
Okay. If there's no other questions in the Zoom, I'm gonna go ahead and close it out, and thank you everyone